Good afternoon, everyone. My name is Tatiana Jenkins, and this is my introduction to data mining midterm taught by Professor Chin. Once again, my name is Tatiana Jenkins from Virginia State University. So the goal of our midterm assignment that we had was to implement hybrid algorithms. So in this algorithm, it included K-means clustering and hierarchical clustering. Each set of clustering will be used to express a certain type of data in a certain way, as you may code it. So what is clustering? Clustering is a task that sets objects together based off their similarities. So when it comes to the similarities, it could be the different numbers, the deviations, and things like that, and they're grouped together to differ from one another. So the differences that will be shown further in this presentation by each type of clustering can be done by color, shape, size, or even in different types of graphs to show the differences. Hierarchical clustering. Hierarchical clustering groups data in a predetermined order. Predetermined meaning that it's already set in stone what the data, when it's implemented into the system and coded properly using this algorithm, will do. So there's two types that we were taught: divisive, which is from top to bottom; agglomerative, which is from bottom to top. The first thing I thought of when thinking of a hierarchical clustering was hierarchy. So when you think about a family tree as shown to the right or to your left, you think about your family tree, it starts with who came before you. So for us, it will be your grandparents, then it will be your parents, then it may be you. Then it may be, if you have children, your children. If you start from bottom to top, it will start with your children or whoever's after you, yourself, your parents, your grandparents, your great grandparents, your great great grandparents, and so forth and so on. K-means clustering is kind of more of an unorganized way in data mining to cluster different data sets, but this algorithm has to be repeated until we find a mode of it. So what is the common ground? So when computing this, the iterates and centroids have to be constantly repeated for each step when implementing data and running this data until a common one is found. So as you can see, prior to the k-means clustering being ran fully through, you can see that on the graph to the left that the data is kind of scattered all over the place, but it's still close enough to see that you can kind of defer which cluster is where. When you do it after and you implement what type of way you like to show your data, it shows in the red, the green, and the blue that that particular set of data objects are grouped together for a particular reason. This could be the numbers, this could be how it was ran, whatever was implemented. The results I did for my coding, I used this particular graph to show when I put the colors in green, blue, and red. Sorry about that. In green, blue, and red to show my clusters, which was my maximum was 3, but this was ran multiple times in order to find my common ground when using this hybrid algorithm. Thank you for your time.